is to understand changing from polar form to the other one, Cartesian form. And in order to do that, you need to know your very basics. Okay, first you need to know R, and you need to know your angle. Okay, and it's very easy. To calculate your R is to use pi tag. So this is your R, right? This is your Cartesian form, by the way. This is R cis, and there's some angle in here. And to find R, you need to do a pi tag. Okay, so do that. And this is your imaginary. Okay, this is your real number, and this is your imaginary number. Okay. And imaginary number, if it hogs the I, that's an imaginary number. If it's nothing, it's a real number, right? Because yeah, I mean it's pretty obvious. So let's first take the first number. This is negative root 2. That squared plus negative root 6. I mean, bracket that square, and what you'll get is you get root 8, which equals to 3 over 2. Alright, I got this question wrong originally, so it's root 8. Alright, don't worry about it. If it has the 3 over 2, you want to make sure you have the right stuff. So R equals to root 8. But how do we find the angle? Even easier. So first you need to understand we have a negative root 6 and we have a negative root 2. In order to do that, you do tan inverse, so arctan. Negative root 6, so whatever imaginary number on top and real number on the bottom, like this, okay? Now, in my previous video, and I had to find out, unfortunately, because I can't be bothered. So you can see the top is negative, the bottom is negative. This is the sine and cos, by the way, because I think that's how it works. Basically, if you go over the Cartesian plane, okay, top is y-axis, so it goes negative, it goes down, and x-axis negative here. So we're in the third quadrant, and according to some bullshit law, alright, in the second quadrant, you need to add pi to whatever in it. In the third quadrant, you need to minus pi, and these remain the same in first and fourth, and this will put it back in principal argument. And so, with what we get here, right, is essentially we will get, if we keep deducing it, this should equal to negative root 3, which would equal to positive, sorry, and then it would equal to pi over 3, right, which is what I got originally. So I'm like, what the hell? And I realized since it's in the third quadrant, because you know negative y, negative x is new minus pi, so you minus pi, okay. And then once you minus pi, then you get what's that? 3, so you get negative 2 pi on 3. Okay, let's get negative 2 pi on 3, and boom, tick tick. All right, easy. Yo, okay, I'm back, guys. So basically, this is the second question, all right. And the second question is pretty simple. You just need to memorize a couple things, okay? And and that couple thing is the formula. And the formula is as follows: R to the power of n times EI times EI theta times n equals the exact same thing to the R, and then it should be something like this: Rn cis something. Okay, so something like that. Okay, we say Rn cis theta times n. Okay, but for our case, we don't really need this. Okay, because who cares about this right now? We need to care about this. So we know R is equal to 2 from above. Okay, so 2 to the power of n was 4. I'm autistic. Sorry. I apologize for saying that. Root R is this, root 8 to the power 4. And I was struggling with this one for a second, right? Root 8 4. I'm like, okay, so root 8 to the squared is 8, and then you cube it, so then it becomes 64. And then you cube it, and then you do the thing, and then you get like, well, I don't know, like 64 times 8, whatever that is. Okay, that's like what, 720. Who cares? That doesn't matter. Alright, this is wrong. Do not think like me. Okay, and if you're laughing right now because you think I'm dumb, then fair enough. Okay, but still, what this shows is root 8 times root 8 times root 8 times root 8. And when root 8 times root 8, that equals to 8. But 8 times another root 8 just becomes this. Right? So then when you times root 8 again, right, then you cancel out this becomes 8, 64, okay? So do not argue, it is 64. So this would be 64. Now what is times En? Okay, so times EI theta. Theta, we clarified, is negative 2 pi over 3, alright? I times 4, okay? And that should give us the grand total of 64 times 64e. I'll just do this because it's easier. 64e. I need better handwriting. Holy. 64e, and then negative 8 pi on 3 because you times the 4i. Okay. This is what you should get. And whoa, principal argument is very important. Now, what do you do in a time like this? Okay, let's take out this for example because we need to put this in the thing. Okay. So it's negative 8 pi on 3. Clearly, it's not in between the principal argument, and principal argument is this. Okay. Something like this. Okay. I think it's this. Basically, the angle has to be between negative pi and pi. Okay. It has to be, no matter what. Okay. And this is clearly way out here, okay? It's way past negative pi already. So what do? So you add 2 pi. And by the way, you can either add or minus 2 pi depending on your situation, but obviously we have to add 2 pi to get it back. And by adding 2 pi, that would give us something like 6 pi on 3. This is 2 pi, by the way. This is 2 pi. That would give us negative 2 pi on 3 again. So it looks like we just did a bunch of nothing, but if we need to do working out, at least we have it. So that is why it's negative 2 pi on 3 and 64 here. Now down here, question 3 is completely unrelated to the thing up here, okay? So we need to first find the polar form, okay? Because z equals I doesn't really give us anything. Well, it does a lot, to be fair, but still. So we know the graph, if you're familiar with it. Y-axis is imaginary numbers and real numbers, okay? And essentially in all maths, okay? I don't even know, I think z or something like that. I don't care anymore. So in all things, in all grand scheme of things, right? In this formula, right, in negative root 2 minus 6 times I, this is what it would look like, okay? It's very clear. Let's see, it's going this way, root 2, and then goes down, root 6, and then it looks like this, okay? That is literally what it looks like. And then it creates some sort of angle, but then because of the third quadrant, you have to add minus pi to get it back into here, something like this, okay? And essentially, right, this whole question 3 made me kill myself. Now I'll tell you why, okay? Z equals I, alright, cool, Z equals I, and I just took it for what it looked like. Okay, so, you know, the arctan, and there's no real number, so I just took the 1, and I thought it was just arctan of 1, tan inverse of 1, and that should equal to pi over 4. However, we need to remember to graph things, okay? Z equals I, Z equals to I, and that's literally it. And what's the angle that makes with the thing? Pi over 2, 90 degrees. Okay, don't get too complicated, remember to graph your thing to consolidate your understanding in this case. So, now we know that angle equals to pi over 2. Okay, R equals to a non-existent, actually it exists, it's just equals to 1, okay? Why? Well, because 1 and there's a 0, there should be, so it looks like this, technically, it looks like the 0, this is the real number, 0 plus 1i, literally nothing more than that, okay? And so that's 0 squared plus 1 squared equals 1, root 1 equals 1, okay, boom. Now we have this, we can formulate our very own polar form, is that right? No, Cartesian form, oops, I need to study it more. So it looks like this, okay? 1 cis pi over 2. Now, the square root is a key value, so what it's telling us is it's annoyed now. It wants to root itself for some dumb reason. And what do you do from now, okay? So we know, because we smart people, you times 1/2, like this. Then you get, oh no, whoops, wrong way, whoopsies. You square it, okay? You square the r by 1/2. So then you get 1, okay? Cis. And then this is very crucial, right? You don't square root, you don't square this up here. Right, very wrong, you times it, okay? So you times 1/2. Then you get 1 cis pi over 4, okay? Now that is your very first, I don't know what this is called, I forgot, let me just check ChatGPT real quick. First iteration, probably? It's whatever this is, okay? It's iteration, who knows? It's something like this, alright? So this is the very first thing you have, okay? And then you don't even look at your second one, because it's 2, okay? And how do I know there's 2? Well, it's because, first of all, it says here already there's 2, but something you can also do is, since it's a square root and there's a 2 at the bottom right, that means there's 2. If it's going to be a cube thing, there's 3, okay? It's very simple. So W2 should equal to this. 1, this, alright, the R doesn't change, I hope you remember, is pi over 4 plus pi. Now, why is this the case? Right? This is nothing to do with the Cartesian form we were talking about before, where you have to add pi minus pi, whatever. But this is because, okay, when we look at square roots, okay, we know that, say this is cis, okay? Cis is essentially a circle, by the way, if you didn't know that. And it's, okay, I don't know if I'm saying it properly, to be honest. Just know, if it's a square root, right, pretend you're going through a whole revolution, and it's split into 2 parts, okay? So you got this part and you got the other part. Okay, something like that. So that's why you add 2 pi on 2, right? Because a whole circle is 2 pi, but you divide it by 2 because we're square rooting it, okay? So, and this would be the same thing if it was a cube root instead. If it was a cube root, that's 1 over 3. You divide that by 3, so it's like 1, 2, I don't know, something like that, and that would be 2, and we have to add 2 pi on 3. Okay, and please don't question it any further, as you can see I'm struggling. But that just equals to pi. So 1 cis, then that should be 5 pi on 4. Okay, alright. So what that should equal to? Principal argument minus 2 pi here. Don't worry about it. If you ask why, it's just because someone decided that. So you minus 2 pi on 4, 5 pi on 4 minus 2 pi, that would equate to negative 3 pi on 4. And as per questions asking from smallest to largest, negative 3 pi on 4 and pi on 4. Okay, that was a long ass video.